Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Science Thursday, we're gonna talk about ventilator. So let's dive right into it. Well, first you have to understand what is our problem. Our problem is that we need to take oxygen, but we also need to exhale carbon dioxide. And lungs are ludicrously complex. To give you a context of that, you can take out almost every simple organs from human body, like heart. Heart can be replaced by a pump. Kidneys, livers, and all that is like you have some levels of control over that. Lungs, on the other hand, it's completely different. Lungs is like almost second only to brain. So alveoli, basically these small air sacs, these are the lifeblood of humanity. Basically, if they work, you're alive. If they don't work, you dead. And there is no easy way of doing this externally. Basically, you cannot like, okay, I'm gonna take your blood from here, I'm gonna pump the blood here, and during this, I'm gonna oxygenate it and remove carbon dioxide out of it. That's not easily doable. So that's the reality of it. Alveoli must work, otherwise the patient is dead. So everything that you see around the lungs, basically from the muscle system of the diaphragm, the windpipe to everything that you see, like actual rib cage and all that jazz, they are acting as a physical support because this alveoli is not a continuous structure. So what happens is basically you breathe in, it's like a rush of air comes in, it has a higher concentration of oxygen than the oxygen concentration in basically in your blood due to osmosis gas exchange itself. Basically carbon dioxide ends up entering in your basically exhaust system, and oxygen enters into your bloodstream. Everything is fine, but it acts as a non-continuous system. It's not like it's continuously. It's like, so you do like that. Now problem with this is basically if it malfunctions, you dead. It's not like, okay, you have kidney failure, you have some hours to think about it. You have liver failure, you have some hours to think about it. Like ulcers and all that jazz, like you have some amount to think about it. This, you did. If this fails, if this alveoli fails to do its job, you did in minutes, like 3 minutes or 4 minutes. Heck, if you're sedated, you may last longer, 10 minutes maximum. So this is the problem of it. Like the priority of this puppy is very high. Then we come to the solution aspect. Now, because we cannot just replace alveoli, we created a machine known as basically ventilator. So what it is external support. It's like we're gonna support the workings of alveoli. Alveoli is like, dude, I need oxygen in it. We are like, okay, we got this. Okay, you are having a hard time taking in oxygen. We're gonna increase the concentration of oxygen, because let's say the normal air is around 20% oxygen, and the person is having difficulty absorbing oxygen. We're gonna be like, okay, we're gonna increase it to 30% oxygen. It's still not working. No problem, no problem. I'm gonna make it 60. Now you're okay. Okay, everything is cool. So that's what we are doing. We are doing all this support externally. We are like, Avila is still doing the main its job. It's not some external machine. It's like we're just gonna allow it to do its job more efficiently. Now this requires monitor and measure, because it's not a continuous system. It's not like, okay, pump oxygen in and then like carbon dioxide will go out from another vent. It's not like that. It's like a rhythm. So it requires continuous monitoring and measure. That's why you see giant LCDs in every ventilator system. It's kind of necessary, because if you don't see it like how it's working over time, or at least 15 seconds or 20 seconds, you will not get a clear picture about that. Now the biggest hurdle with this system is, even though you can mass produce the machine, you need a respiratory therapist. If you are familiar with any operational series, or if you have been in an operation, you must have seen there are more than one people inside. So one of them would be like, anesthesiologist, whose sole job is like, knocking you out. Another person would be this guy, whose sole job is to make sure, because you are generally in general anesthesia, if it's severe enough, it's gonna disable your muscle system that is operating your lungs. Lungs cannot go on vacation. So what do? This respiratory management system will be like, okay, I got this. The person is not breathing on its own. I'm gonna do the breathing for it. Alveoli is still doing the work. The blood oxygenation is directly happening on there only, but you are supporting it externally. It's like your muscles are not working. No problem. I got this. So that is the solution we employed. Now, control factors, how many things it has to control. Now this is where you will see many designs on internet. It's like, we are working on low cost. Most of them are gibberish, basically flat out, and not out of bad intent. It's not like they want to harm it. It's just that most people don't understand how deep this rabbit hole goes. And heck, even like I've tried to went into the rabbit hole, and I'm like, dude, it goes way too deep. Even though it's quote unquote a machine and simple thing, it's ludicrously complex. So just to give you an overall idea how many things, how many valves and management system you're gonna need, let's start with like electronics parts of this is easy. Everything else is the hard part. So we need oxygen mix control. That is the step one. Basically, if you have any inflammation or things of that nature where your alveoli are not working at peak efficiency, you're like, okay, we're gonna give you more oxygen. So you can do this easily. Then you're also gonna monitor carbon dioxide output, because again, we don't have another exhaust valve. It has to come out here. So Oxygen mix, carbon dioxide output, temperature and humidity. Because ventilators generally needed to directly go into your lungs. So what they do, either they can drill through here, generally not recommended. So what generally people do, they will have basically a machine that will help you. It's not a machine, it's a spike kind of. I have provided the animation number below, and they're gonna have a tube that directly goes through your vocal cord. Basically, it will go here, and they're gonna inflate a balloon on that, and it's gonna lock itself so it does not pull out accidentally. And during this time, you will be sedated. Now it's pumping directly air into your lungs. Good news, you're gonna go through any blockage and all that. Side effect, your nasal cavity, basically this whole system is there to manage the temperature and humidity of it. So even if air is dry outside, your lungs are not exposed to it, because alveoli is very thin and very fragile. So it has an optimum range of like, okay, humidity must be at least this much. Come on, man, it has to be this much. Temperature has to be there. You do not want to put like 20 degrees Celsius air or whatever the temperature is. Like ask a doctor, it's like what temperature the alveoli most prefer. So you have to control temperature and humidity. Without this control, you may be roasting their lungs slowly. That's the 2 point. Then we come to inflation and deflation pressure. Now you must have seen people are talking about these ventilators as positive pressure. There used to be negative system, which was like basically we're gonna clamp you in a quote unquote iron lungs, and that's gonna have a partial vacuum. So when there is a partial vacuum, your lungs will automatically expand, and doing this, you're gonna do the negative pressure. Your lungs will suck in air. That's no longer preferred. People generally use positive pressure. Basically, you are pumping air in the positive stroke. So that's the inflation and deflation pressure. You have to monitor both sides. It's like if deflation is happening too severely, that means something else is getting damaged. And if this has to be monitored basically. And then we come to the most critical aspect in this pandemic: minimum back pressure. Because the infection is directly damaging alveoli. Actually it's not damaging, it's like going it, infecting it, and immune system is blasting it out of orbit. Side effect is alveoli is very fragile. So once it gets damaged, if you breathe out, there is because again it shrinks, but its weakened state, it could literally collapse. Now, when the collapse happens, you dead, because your air sac is no longer working. You cannot open it up again, and you cannot blow air in it to open it up. You will damage it more, whatever remaining alveoli you have. So that is why minimum back pressure is such a critical component right now. You must like, okay, you want to exhaust her, I'm gonna pull the air out of it, but will not let you drop the temperature. Basically, lungs, let's say, wants to go to from 15 psi to 5 psi. You'll be like, no, don't drop to 5 psi. You are in 2 weeks of a state. If you go to 5 psi, you're gonna collapse. You're like, okay, let's stay at 10 psi. Now again, ask a doctor. These numbers are just a reference idea, but that is very critical, and it is different for every person. That's also another frustrating. It's not like, okay, you have this infection, make it a 10. No, again, if you are at 70-year-old, you will be different. If you are 30 years old, it will be different. Then air volume control, how much air you are pumping into something. Basically, if they have basically lung puncture wound due to infection or tumor or things of that nature, you may have a scenario where air is directly leaking in. That is very bad. So you have to monitor the volume, and that volume whatever you are monitoring, you have to monitor the change into it. Like if the person's condition is getting bad and worsen over time, that means they are filling up with basically fluid, you have to know that. So for that reason, volume control is very critical, and you never want to stress it out. Like you cannot be like, okay, water is filling in, let's say fluids are filling it, I'm going to pressurize it. Now you're going to destroy the whatever remaining one is there. So you have to compensate for the pressure, but not too much. You don't want fluid to directly suffocate the person. Breaths per minute. Now this is very easy, but here's the deal: humans do not breathe in a continuous manner. It's not like we don't have 15 breaths per minute. It's like 15 breaths per minute. On mathematically it sounds good, but you will be like, okay, normally you are breathing and then you're like, take some deep breath. Sometimes you will take some short breath. These natural rhythm is necessary for survival. It's not something that you can postpone. Now again, for short term, let's say your case is very badly deteriorated, then doctor can be like, okay, put in an emergency 15 breaths per minute. It's like it's gonna do it no matter whether you want it or not. Now generally they do not want to put you in manual mode for longer. Generally they want to put you in quote unquote adaptive mode. So what adaptive mode does is monitoring. It's basically your lung pressure is starting to, that means you want to inhale, I'm gonna give you option. Now pressure starts to go up, it's like, okay, I'm gonna exhaust it out of you. It helps you. Basically, however you are breathing, it's just helping you. It's acting as a support. Now that is very critical, because if that does not happen, you cannot remove the person from the ventilator. You want that person to be ventilated as small duration as possible. You do not want them, hey, just chill on ventilator. That's not recommended. And because it's a life critical system and it has to work, it is classified as a basically fail safe with reliability, aka if anything happens, let's say a power spike, it must have an electrical system strong enough that is like, I don't give a damn if lightning fall on the wiring system, it must handle it. It does not give a damn like you have power outage, it must have either battery backup or a alarm system or a passive fail safe system, like okay, I'm stopped working, I'm not gonna suffocate the person, I'm gonna go in positive oxygen pressure or whatever, like minimum fail safe state is there. It has to do all of that. These are the control factor on a basic level. So if you see something that is just air doing like this, again, it needs way too much control on top of that. So you will need a lot of support structure. Some hospitals already have oxygen line, vacuum line, and pure air line. All those things combined could make a ventilator very small. You could have a ventilator very small, but again, you still have to figure out the humidity control and moisture control and all that jazz. Temperature also, because if too many people start to drain oxygen from a central line, the temperature could drop. So control factor is very critical. That's why you have so many knobs and dials and touchscreen and 20-inch Tesla touchscreen. So what are the side effects of this ventilator? Again, alveoli are way too fragile. It's not like your muscle where it's gonna heal and get stronger as you grow older. It's very fragile. It's in many regards much more fragile than your other organs. So it can be easily damaged. And you must have heard people already saying their horror stories, like their lungs are damaged because of the ventilator. If ventilator setting is wrong, it's literally damaging your alveoli. So that's something a person has to take very serious care about. Now patients need to be sedated because you literally have this thing directly going through your vocal tube, and it's like they remove the flap and then directly have that. The person cannot be awake. It would be like they are suffocating. Like if people come awake during that time, because you don't want to sedate them for that long, you generally put them on heavy sleep medication, but for some reason they start to wake up, they'll try to pull it out because it feels like that suffocation. So that also sedation is also issue. Again, if you have to sedate someone for 1 day, no problem, but you have to sedate them for 2 weeks, which is needed in this pandemic. Yeah, that's another danger. Then continuous monitoring. Now this is where Italy is starting to realize that doctors are fallible creatures. Basically, even though you can train them, even though they are like, no, I know exactly what to do, if they have to do 17-hour shifts every day, they will make mistakes, and that mistakes will cost life. Like that is the another aspect. Like even though you could have ventilators, unless you have basically what we classify as respiratory therapist, you did. Like you can literally have hundreds of free the system. It is very deadly without it. Like unless somebody is there like monitoring every single patient, it's very deadly, and it cannot be automated. You cannot be like, okay, what if there is a computer system that is doing all that? You have to create a computer system that is an actual doctor which can understand, if this is happening, this is what I have to do. And it has to know full pipeline of like, okay, if this infection happens, this is the pneumonia outcome, this is the main base case scenario, and this is how the 70-year-old reacts, this is how a 75-year-old reacts, this is how a 30-year-old reacts. Yeah, that's not automatable as of now. Again, in the future maybe we are able to automate it, but right now you need that person who's like, I know what I'm doing. And even they have a limitation. In a pandemic they will be like, swamped, and 24/7 work hour, yeah, they're gonna make mistakes. So we talk about let's talk about the most talked about topic. It's like mass production. We are on short of it. Well, technically we are short on everything, simply because a civilization relies on majority of its people being healthy. You cannot have a civilization if like even 1%, one whole percent of people are sick. What we have is generally beds are counted in per thousand. So if best case scenario is like you're gonna have 5 beds per 1,000 people. And now a pandemic requires you to have beds like per 500. Basically per 1,000 you have to have 500 beds. That's 50% hospital capacity. That cannot be done flat out, because a hospital needs hundreds of people working continuously to supply that hospital, from electricity to water to supplies to medications to other therapists to x-rayologists and all that jazz. That's the reality of it. You cannot design for pandemic. That's why it's called pandemic. So anything can be mass produced. Many of you are familiar of with old World War stories. You know for a fact that people reached to a point where they were mass producing tanks per hour. It's like tank, even more tanks. And then people who built bombers, they even reached to that high speed where they're like, okay, a bomber and bomber. So why can't we just magically make ventilators out of it? Well, because ventilator is such a complicated thing. In terms of electronics, it's child's play. Even a normal Android phone is like, bro, I have more than enough processing power to handle this few variables. Like, I got this, not an issue. But problem is the valves, the control mechanism, the moisture control, all those things, those are physical entities. They are required design validation. So you cannot just magically make something. You have to validate that, and testing is the hard part. So if you want to sit down as like, okay, I'm going to design a ventilator, that would take you 1 week or 2 weeks if you are a good engineer. But to test it, validate it, it could take one whole year. The reason for that is simply because you have to design it in such a way that is like, okay, it's saved for first 10 passenger, but after a while there was a valve leak or this pipe broke because of the friction and all that, just and then our patients afterwards started dying. That cannot be allowed to happen. So to say, that is why validation and testing is like, such an important state for medical equipments, and that's also another reason why medical equipments are so expensive. So best case scenario is basically you take whatever factory that is working on it, already designed, already verified, you like just double the production. Then come the another side fair. This has been done. Every company that makes ventilator as a like primary job, as a primary organization purpose, they are already reaching a point where they have supply chain disruption, aka they're running out of material due to stock market. Most companies do not have like, okay, we have raw material for 1 year. They generally have raw material for 1 month at best case scenario, 2 months maximum. So the problem is, if you start producing at much faster rate, let's say you got extra people, or even those people, instead of working, let's say 6-hour shift, they are working 12-hour shift. Okay, let's say we are pushing them, but let's say you are doing that and you are like, hey, don't give a damn about quality control in terms of optics. Basically, if it has it looks bad, don't give a damn about it. As long as you work and safe, ship it. Let's say you're doing it. That's the easiest way to increase your production. Problem is, the supply chain would be designed for 2 months of overhead. It will run out in 1 month, or if you are tripling your output, it will run out much sooner. So that becomes another headache. Then you have logistic management. You cannot only just sell this, you have to track them. Why you have to track them? Because if there is any flaw in any of the system, you have to double check it. You have to be like, okay, hey, this valve, this ventilator stopped working, why is that? You have to analyze it, tear it apart, and like, okay, everything is okay, this was bad unit, this one, okay, everything is fine. What if there was a flaw? Let's say this motor stops working after like 80 hours or something, or a transistor stops to work. You have to have the ability to recall all of them, otherwise you are putting other people's life in danger. So all of these things we can easily do. That's not the hard part. Hard part is doing this in a short time. It cannot be done flat out. If you see a mobile phone in your hand today, I can guarantee somebody planned it out 2 years ago, flat out. Like, okay, I'm gonna buy plastics from here. So it will be like, if they are doing everything in one place, it will be like, okay, I'm gonna buy the crude oil from here, I'm gonna buy some additive binders agents from this guy, and I'm gonna buy the metals from here, then I'm gonna alloy it, and I'm gonna do all these things. How I'm gonna make it into screws. There's a very long chain. That chain takes time. So I can easily see, like right now, doubling output of our respirator, but to make it 10 times or 20 times, that will take some time. But by the time August and December comes around, I'm reasonably sure by that point we will be mass producing ventilators like there is no tomorrow. At that point, that issue will be solved. However, then we'll have another issue known as lack of doctors. So it's a very dark scenario. So this was my presentation on very stressful topic. I hope you liked it, learn from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I'd urge you to press dislike, press it twice to show me extra disappointment, and please leave a comment because I try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.